On one successful coding task, DeepSeek looked almost 3 times slower than GPT-5.6 Luna and more expensive. That was the opposite of the low-cost agent story we expected. But the result came with a warning hidden in the token ledger. The two runs had radically different cache mixes, so we stopped treating one clean finish as a verdict. We rebuilt the comparison as 18 fresh runs. The answer changed. Luna completed one more task, DeepSeek posted the shorter median, and the Azure Luna deployment cost more than 20 times as much per success. This video is about why all 4 facts can be true at once. The official release ID is DeepSeek AI DeepSeek v4-731, a sparse mixture of experts model listed by OpenRouter at 284 billion total and 13 billion active parameters. DeepSeek reports strong agent results, including 82.7 on Terminal Bench 2.1 and 70.3 on Tulathlon Verified. Those scores use DeepSeek's minimal harness, max reasoning, temperature 1, and top P 0.95, not our conditions. Before benchmarking, we called the hosted deployment DeepSeek v4-0731 on DeepInfra via OpenRouter. 2 API turns returned HTTP 200, produced a valid inventory tool call, correctly interpreted the result, and finished in 5.239 seconds for $0.008834. Next came a real file repair task. Both successful runs made 5 API calls and passed 4 visible plus 5 hidden tests. DeepSeek took 59.56 seconds. GPT-5.6 Luna took 21.17. Catalog estimates also made DeepSeek look 2.63 times costlier. But compare input accounting. DeepSeek had 30,567 uncached input tokens and only 5,376 cached. Luna had 5,085 uncached and 28,160 cached. This was one task, successful runs only, and not a reliability ranking. Luna had also produced one earlier 300-second stall before any tool call. The evidence did not tell us that DeepSeek was simply slower or costlier. It told us cache behavior was dominating a tiny sample. The correction was a fixed minimal harness. Each deployment received 3 tasks: inventory, event rollup, and dependency batches, with 3 fresh repetitions each. Reasoning effort was high. Seeds were 1001, 1002, and 1003. Every run had at most 12 model turns and 3,000 output tokens per response. The agent could read files, write only solution.py, and run visible tests. Hidden tests stayed withheld and were executed independently. Provider fallback was off. The exact deployment cards were DeepSeek v4-0731, DeepInfra via OpenRouter, provider reported FP4, and OpenAI GPT-5.6 Luna, Azure via OpenRouter, provider managed. This isolates a harness comparison better, but provider and deployment differences remain part of the result. Luna's Azure deployment completed 8 of 9 runs. The exact model ID was OpenAI GPT-5.6 Luna, served by Azure via OpenRouter. It passed every visible suite, but only 8 hidden suites. Inventory and event rollup were 3 for 3. Dependency batches was 2 for 3. The failed solution accepted an empty service name and duplicate dependencies when the contract required value error. Median wall time was 17.44 seconds, with 4 median turns. This is the key separation. The agent's visible feedback said all 9 were good, while independent hidden verification removed 1 from the success count. DeepSeek's DeepInfra deployment completed 7 of 9. The exact model ID was DeepSeek v4-0731, served by DeepInfra via OpenRouter. Again, visible suites showed 9 of 9, but hidden suites showed 7. Dependency batches was 3 for 3. Inventory and event rollup were each 2 for 3. Both failures hit the same boundary. A none item reached .get and raised attribute error instead of the required value error. Median wall time was 15.80 seconds, with 6 median turns. The model was not failing the main happy path. It was missing a validation contract that the visible suite did not expose. Now the scoped comparison. Luna completed 8 of 9. DeepSeek completed 7. With 9 trials per deployment, that one-run gap is directional, not statistically conclusive. DeepSeek's 15.80-second median was 9.37% shorter than Luna's 17.44 seconds. Cost moved much more. DeepSeek totaled $0.0594730 and cost $0.49615 per success. Luna totaled $0.37185 and cost $0.74825 per success. In these DeepInfra versus Azure deployments, Luna cost 20.18 times more per successful run. That does not mean Luna is always 20 times more expensive. It means this Azure route, under this harness and matrix, had that measured ratio. The operational verdict is narrow but useful. DeepSeek v4-0731 on DeepInfra is viable for low-cost coding agent work in this harness. Its median was slightly shorter, and successful work cost about 4.95% of the Azure Luna deployment. Luna delivered one more verified completion and needed fewer median turns. Neither visible green tests nor a confident final message was enough. Hidden contract checks changed 3 outcomes across the matrix. For this kind of work, the result supports testing DeepSeek behind a deterministic completion gate that can catch validation mistakes with repair or fallback available. Luna's one additional verified completion is also real, but 9 runs are not enough to turn it into a universal routing rule. Keep monitoring with more tasks and repetitions. Installment 2 asks what remains when this model is pushed through extreme local quantization.